Good morning friends, welcome back to Panika Tutorials. In the last few videos I have discussed about first in first out page replacement algorithm and the issue with the first in first out page replacement algorithm. I hope you have watched those videos. If you did not watch them, I request you to go back and watch those two videos and come back to this video. In this video I want to discuss about optimal page replacement algorithm with an example. So I request everyone to watch the complete video for better understanding. Look at this example. The CPU is trying to access the page number 476, 176, 127, 261, 27, and the main memory is logically divided into 3 frames, frame 1, frame 2, frame 3. If you have 3 frames in the main memory, at max you can keep the 3 pages. Let's assume that 3 pages are already there in the main memory. Now CPU is trying to access the page which is not currently available in the main memory. To execute that one, you have to insert into the main memory. If already main memory is full, then what you need to do, you have to remove one of the existing page and then you have to insert. So removing one of the page from the main memory and keeping it into the secondary memory, we'll call it as a swap out, and bringing the page which is currently available in the second memory to the main memory, we will call it as swap in. So we need to find the page which we need to replace. Am I right or wrong? Now, when it comes to the first in first out page replacement algorithm, the page which was inserted first will be removed first. Okay, now in the optimal page replacement algorithm, pages are replaced which would not be used for the longest duration of time in the future. Now what you have to look at is, if you want to remove any particular page, you need to look at the future references. If the particular page will not be referred for a longest duration, then you will remove it or you will do the swap out, and the page which you want to insert, you will do the swap in. I hope the algorithm is clear for you. If you did not understand, don't worry. I will discuss this concept with the given example. Now page number 4, the CPU is trying to access. Whether the page number 4 is available in the main memory, it is not available. So it is a page fault. Okay, for executing that one, you have to bring it into the main memory. So I have inserted in the page number 4 in the frame number 1. Okay, now page number 7, CPU is trying to access, which is currently available, it is not available. So again it is a page fault. What is meant by page fault? The CPU is trying to access a particular page. If it is not available in the main memory, then we will call it as a page fault. If it is available in the main memory, then we will call it as a page hit. So page number 7 is not there, so it was a fault. So we have inserted the page number 7 in the frame number 2. Now page number 6, CPU is trying to access. Whether it is there, it is not there. So again it is a page fault. So you need to insert the page number 6 in the frame number 3. Now the main memory is full. Now CPU is trying to access the page number 1. Whether page number 1 is available, it is not available in the main memory. So again it is a page fault. Now as the main memory is full, we have to remove one of the existing page which is currently available in the main memory and replace with the 1. Am I right or wrong? So which page I have to remove? It depends on the replacement strategy. As we are discussing the optimal page replacement algorithm, you need to look at the page number 4 when it will be refer again. It will never refer. Page number 7, it will be refer here. Page number 6, it will be refer here. So if I have the page number 4, it will not be referred again, so it is no use. So I will swap out the page number 4 and I will swap in the page number 1. So currently page number 1, 7, 6 are there in the main memory. Now page number 7, CPU is trying to access. Whether it is currently available in the main memory? Yes, it is available. So we no need to do the swap out and swap in. The same pages will be there in the main memory. And CPU is trying to access the page number 6. Whether page number 6 is available? Yes. If it is available, we will say that it is a page hit. If it is a page hit, we no need to do the swap out and swap in. Page number 1, yes, it is available. So it is a page hit. So same pages will be there. Now page number 2. Page number 2 is there in the main memory? It is not there. If it is not there, it is a page fault. If it is a page fault, to execute this particular process, we need to bring the page number 2 into the main memory. Already the main memory is full, so we have to remove one of the existing page and keep the page number 2. So which one we have to remove? That depends on the replacement algorithm. As we are using the optimal page replacement algorithm, we need to look at the future references. Page number 1 will be referred here. Keep it here. Page number 7 will be referred immediately. Page number 6 will be referred here. So which page will be referred after the longest duration? Page number 1. So we will swap out the page number 1 and we will swap in the page number 2. So page number 2, page number 7 and page number 6 are currently available in the main memory. Now CPU is trying to access the page number 7. Whether page number 7 is there in the main memory? Yes, it is there. So it is a page hit. So the same pages will be there in the main memory. And page number 2, CPU is trying to access. Whether it is there in the main memory? Yes, it is there. So again, it is a page hit. So same pages will be available. Are you able to understand? Now 6. Page number 6, the CPU is trying to access. Whether it is there in the main memory? Yes, it is there. So again, it is a page hit. So same pages will be there in the main memory. Now page number 1. Page number 1 is there in the main memory? It is not there. So it is a page fault or page miss. So what you need to do? We have to find one victim page and we have to swap out that particular page and we have to swap in the page number 1. Which one we have to swap out? That depends on the future references. Look at the next references. Okay, 2, 7. So 6 will not be referred again. So what you need to do, you have to swap out the page number 6 and swap in the page number 1. So you have the pages 2, 7, 1 in the main memory. Now page number 2, yes, it is there. It is a page hit. So same pages will be there in the main memory. Page number 7, it is there in the main memory. So again, it is a page hit. So you no need to do the swap out and swap in. So finally you have the page number 2, page number 7, page number 1 in the main memory. Is it clear? So now we need to find the number of page faults. You need to count 1, 2, 3, 4, 5, 6. 6 page faults are occurred. 4, 5, 6. Okay. Number of page hits. 1, 2, 3, 4, 5, 6, 7, 8. So hit ratio. Hit ratio, how we will compute? Number of hits by number of references, which is 6 plus 8 into 100, which is equal to 8 by 14 into 100. If someone asks you find the miss ratio or page fault ratio, how you will compute? You will compute the by number of faults, page faults by total references, which is 8 plus 6 into 100. So this is the way you can do the optimal page replacement algorithm. If you still have any doubts related to this concept or related to this example, feel free to ask me in the comment section. I request everyone take the same string and consider the 4 frames in the main memory and find out number of page faults and number of page hits. And please do it and write the answer in the comment section. If your answer is right, I will appreciate. If your answer is wrong, I will correct you. Thank you for watching the complete video. Have a nice day.